Hello everyone, I am Swarnalatha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on probability and random variables. The first problem is, assume that the number of automobiles arriving at a gasoline station is Poisson distributed and occur at an average rate of 50 per hour. The station has only one gasoline pump. If all cars are assumed to require 1 minute to obtain fuel, what is the probability that a waiting line will occur at the pump? So what they have given that? They have given that the automobiles which are having at a gasoline station are like Poisson distributed. So the type of random variable here nothing but what? Poisson random variable. Next, they are occurring at an average rate of 50 per hour. It means for 1 hour, how many cars are coming? 50 cars are coming for 1 hour. So this is in terms of hours. If you want to change in to minutes, then 50 by 60 per minute. Nothing but what? 5 by 6 per minute. Next one. The station has only one gasoline pump. If all the cars are assumed to require 1 minute, if all the cars are required 1 minute to obtain the fuel, then what is here? The time duration of interest T equals to here 1 minute. So here they have given 50 per hour, here they have given T equals to 1 minute. So you have to change into same time, either change this into hours or else this change hours into minutes. Then what you have to calculate, what is the probability that a waiting line will occur at the pump. So therefore, what is given data? The average rate. The number of cars are coming at this station, nothing but lambda equals to 50 per hour. Nothing but in terms of minutes, 50 by 60 per minute. Next, what is the time duration of interest? Here T equals to 1 minute. Then what is B equals to lambda into T. So what is lambda here? 50 by 60 into what is T here? 1. Therefore, what is B equals to 5 by 6. Next, what you have to calculate? What is the probability that a waiting line will occur at the pump? So when do you get the waiting line? If and only if the number of cars at the station are more than 1, then only you are getting the waiting line. So when can you get the waiting line? The number of cars. If 2 or more cars are arrive at the gasoline station, then only you are getting the waiting line. If only 0 car or 1 car is there is no waiting line. More than 1 car, nothing but 2 or more cars are there, then only you get the waiting line. Therefore, the probability that a waiting line occurs can be obtained by evaluating what? P of x is greater than equals to 2. How can you write P of x is greater than equals to nothing but 1 minus P of x is less than equals to 1. That equals to what? 1 minus fx of 1 minus fx of 0. Rs you can write in this as what? 1 minus, so this is 1 minus fx of 1. Because P of x is less than equals to x is nothing but what? Fx of x. So 1 minus fx of n. Or else 1 minus P of x is less than equals to 1 is nothing but less than equals to 1. That is nothing but what? It may be 1, it may be 0 or minus 1 and so on. But the number of cars will be always positive values only. Therefore, P of x equals to 0 plus P of x equals to 1. Now, what is the probability that Px of x equals to k? Nothing but what? E power minus b into b power k by k factorial. Rs can write down here. What is fx of x equals to e power minus b into sigma k equals to infinity b power k k factorial by u of x minus k. Now, fx of 1. So, what is fx of 1 now? E power minus b, nothing but here 5 by 6. Sigma k equals to 0 to infinity b power k. So, what is b here? 5 by 6. Power k. What is k here? K is nothing but 0 to infinity by k factorial into u of x minus k. So, in place of x here I have what? 1. So, 1 minus k. So, if you expand this summation, then you will get 5 by 6 power 0 by 0 factorial. For k equals 0, you are getting u of 1 plus 5 by 6 power 1 by 1 factorial into if k equals to 1 u of 0. And for k equals to 2 you are getting u of minus 1 and u of minus 0. So what is u of minus 1? U of minus 2 nothing but 0. Therefore you can write this as what? E power minus 5 by 6 into, so 5 by 6 for 0 is equal to nothing but 1. And what is u of 1 value? 1. So 1 plus 5 by 6. 1 factorial nothing but 1. U of 0 value equals to 1. What is u of x actually? The unit step function nothing but it is 1 when x is equals 0 and 0 when x is less than 0. So then what is fx of 1 equals to e power minus 5 by 6 into 1 plus 5 by 6. Then what is p of x equals to? That is nothing but 1 minus fx of 1. So 1 minus, what is fx of 1 value? E power minus 5 by 6 into 1 plus 5 by 6. If you simplify, we are going to get 0.2032. So this is one method, or else you can write down like this also. P of x is greater than equals to nothing but 1 minus P of x is less than equals to 1. That equals to 1 minus P of x equals to 0 plus P of x equals to 1. Nothing but probability that no cars are weighing and probability that only one car is there. That equals to, then what is P of x equals to k for Poisson random variable? E power minus b by b power k into k factorial. That equals to 1 minus, what is k here 0. So and what is b here? 5 by 6. So 5 by 6 power 0 by 0 factorial plus p of x equals to 1. So here k equals to 1. And what is b value? 5 by 6. So e power minus 5 by 6 into 5 by 6 power, what is k value here? 1. So 1 by 1 factorial. So like this also you can find out the probability such that there is no waiting line occurs at the gasoline station. Next problem. Find the value of c for a random variable x which is having the probability density function fx of x equals to c into 1 minus x power 4 for minus 1 less than x less than 1 and 0 otherwise. So what you have to calculate? They have given what? They have given the probability density function of the random variable x. So which is nothing but what? C into 1 minus x power 4 for what values of x? When x is from minus 1 to 1 and 0 otherwise. You have to calculate the value of c. So in order to calculate the value of c, you have to use the properties of the probability density function. What is the property you have to use? The area under the density function is equals to unity. The area under the density function is equals to 1. Therefore, integration. So, what is here? The density function is defined only from minus 1 to 1. So, minus 1 to 1 c into 1 minus x power 4 dx equals to 1. Now, if you simplify this, c into integration of 1 is nothing but x minus integration of x power 4 nothing but x power 5 by 5 and the limits are from minus 1 to 1 that equals to 1. Now that equals to c into substitute the upper limit. If substitute the upper limit, what can happen here? 1 minus 1 by 5 minus, so in place of what is the lower limit here? Minus 1. So minus 1. So minus of minus will get here plus. So plus 1 by 5 is equals to 1. It implies c into 1. So minus of minus 1 here plus 1. So minus 1 by 5 and here minus 1 by 5 minus 2 by 5 equals to 1. It implies c into 2 minus 2 by 5 equals to 1. It implies c into, so 5. To take the LCM, then you get 5 into 2. So 10 minus 2 equals to 1. That implies c equals to what? 5 by 8. Therefore, what is the value of c equals to 5 by 8? Which can be calculated by using the properties of the probability density function. The area under the density function is equal to 1. This is a formula to calculate the value of the c here. Next problem. Find the value of k and also find p of 2 less than equals to x less than equals to 5. Let x be a continuous random variable with the density function fx of x equals to x by 9 plus k when x is from 0 to 6 and 0 otherwise. So in the similar manner how you have found the previous one, same manner you can calculate the value of k. So what is the first one you have to do? We have to find out the value of k. For that, what is the condition here? The area under the density function is equals to 1. That is nothing but integration 0 to 6 x by 9 plus k into dx equals to 1. That equals to integration of x by 9. What can you obtain here? X square by 18 plus integration of k with respect to x is k into x, and the limits are from 0 to 6. That equals to what? 1. That implies substitute the upper limit. What is the upper limit here? 6. So 6 square by 18 plus 6 into x minus, if you substitute the lower limit, you are going to get 0 here, is equals to 1. That implies 36 by 18, nothing but what? 2. And here 6 into k plus 6k is equals to 1. That implies 6k is equals to minus 1 and k equals to what? Minus 1 by 6. So now we have calculated the value of k. Next, what you have to do? We have to find out the probability of the random variable takes from 2 to 5. Then how do you calculate p of 2 less than x less than 2 less than equals to x less than equals to 5? So for this also you have to find out you have to use the properties of the density function. So the probability of any random variable takes from x1 to x2 is equals to what? Integration of the density function over the limits x1 to x2, so that gives a probability of that random variable within the given limits. Similarly here, integration 2 to 5 fx of x into dx. So when 2 to 5, what is fx of x here? X by 9 plus k. What is k value here? Minus 1 by 6. So when it is 2 to 5, so x by 9 plus k. What is k value here? Minus 1 by 6. So minus 1 by 6 into dx equals to, now integrate this function with respect to x, you will get x square by 18 minus 1 by 6 into x, and the limits are from 2 to 5. Now substitute the upper and lower limit, then what can you obtain here? So 25 by 18 minus 5 by 6 minus 4 by 18 minus 2 by 6. So if you take the LCM 18, then what is the LCM of 18 comma 6? Nothing but, so 18. So take the LCM as 18. Then what can happen here? 25 minus, so here 15 minus 4 and here plus 6. That equals to 31. 25 minus 15. No? So 25 plus 6, 31. So minus 19. So we'll get 12. So 12 by 18. Therefore, what is the probability such that the random variable takes from 2 to 5, nothing but 12 by 18. Next one is, a shipment of components consists of 3 identical boxes. How many boxes are you having? 3 boxes. One box contains 2000 components, of which 25% are defective. And the second box has 5000 components, of which 20% of the components are defective. And the third box contains 2000 components, of which 55% are defective. Next, a box is selected at random and a component is removed at random from the box. What is the probability that this component is defective? After that, what is the probability that it came from the second box? So what they have given here, a shipment consists of how many boxes? Consists of 3 identical boxes. Let us say B1, B2, B3. Consists of 3 identical boxes. And in the box B1 contains how many components? 2000 components, of which 25% are defective. And the box B2 consists of 5000 components, of which 20% are defective, and box C consists of 2000 components, of which 55% are defective. After that, a box is selected at random. So how many boxes are you having? 3 boxes. Then What is the probability that selecting the box B1? Nothing but 1 by 3. Totally having 3 boxes, out of that you have to select 1 box. Then what is the probability that selecting box B2 equals to 1 by 3? And probability that selecting the box 3 nothing but 1 by 3. So a box is selected at random and a component is removed at random from the box. So from that box they have taken one component. Then what is the probability that the component is defective? So we don't know from which box that has been selected. So you have to find out the probability that the component is defective. It means in order to solve this, you have to use a total probability. So first let us write down what is the probability that selecting the box is equals to 1 by 3. And let us D is the event which is nothing but selecting the defective component. We don't know whether it is selected from either box B1, B2 or B3, but D is the event such that selecting the defective component. For example, this is a shipment which consists of 3 identical boxes B1, B2, B3. So you have to define one event on these 3 boxes such that you are defining one event D. What is that event D? Selecting a defective item. Whether it is from B1, B2 or B3, we don't know. That D is the event which has been selecting a defective component. And what they are given that? They are given that 25% components are defective in B1. Therefore, what is probability that selecting the defective component and it is given that the component has been selected from the box B1. Then what is P of D by B1 equals to 25%. What is 25%? Nothing but 25 by nothing but 0.25. And second one is what? They have given 20% components are defective from the second box. It means probability that getting the defective item from the box B2. From the box B2, nothing but 20%. So 20% nothing but what? 0.2. And what is P of D by B3? Nothing but probability that selecting the defective item and it is given that the defective item has been selected from the box 3. Then what is that probability are given? 55%, nothing but 0.55. Next, what you have to calculate? You have to calculate the probability that the component has been defective. It means in order to calculate that, you have to use a total probability theorem. Then what is the theorem? P of D equals what? P of D by B1 into P of B1 plus P of D by B2 into P of B2 plus P of D by B3 into P of B3. Substitute the values and then calculate. So then what is the probability getting? P of D, the defective item equals to 1 by 3. Next, this is the first question we are done. What is the second question? What is the probability that coming from this second box? Nothing but probability that selecting the box B2 and it is given that the item is, the component is defective item. What you have to calculate? The probability that the defective component came from the second box. Nothing but probability that selecting the box B2 and given that the defective, it is a defective component. Then for that you have to use a base theorem. What is the base theorem? P of B2 by D equals to P of D by B2 into P of B2 by P of D. So what is P of D by B2? What we have done? Nothing but 0.2 into what is P of B2? 1 by 3 by what is P of D here? 1 by 3. Therefore, what is P of B2 by D equals to 0.2. Next question. The lifetime of IC chips manufactured by semiconductor manufacturer is approximately normally distributed with a mean is equals to 5 into 10 power 6 hours and the standard deviation of 5 into 10 power 6 hours. A mainframe manufacturer requires that at least 95% of a batch should have a lifetime greater than 4 into 10 power 6 hours. Will the deal be made or not? You have to calculate. So what they are given that the lifetime of the IC chip, let us consider the lifetime of the IC chip has been represented by the random variable x. So it is approximately defined by what? The normally distributed. Nothing but what? What is the type of random variable here? The Gaussian random variable. And what they are given that? The mean. So what is that mean of that? The lifetime of the IC chip they have given as what? X bar equals to 5 into 10 power 6 hours. And the standard deviation sigma x is equals to, is also same, nothing but 5 into 10 power 6 hours. Next, what you have to calculate? A mainframe batch requires that at least 95% of a batch should have a lifetime what? Greater than 4 into 10 power 6 hours. Then you have to calculate will the deal be made or not. So first what they are given? They have given the mean, they have given the standard deviation. So let z equals to what? X minus x bar by sigma x. Z equals to, so what is x here? What you have to calculate? You have to calculate what? It is greater than 4 into 10 power 6. So what is you have to calculate? P of x is greater than or equals to 4 into 10 power 6. Nothing but P of z is greater than x minus mu x by sigma x. So what is P of x is greater than or equals to 4 into 10 power. So P of x is greater than x. Then nothing but what? P of z is greater than x minus x bar by sigma x. Therefore, P of z is greater than. So what is x here? 4 into 10 power 6 minus what is x bar? 5 into 10 power 6 by sigma x. What is sigma x here? 5 into 10 power 6. Nothing but P of z is greater than equals to minus 0.2. Nothing but 1 minus P of z is less than equals to minus 0.2. That equals to what? 1 minus pi of 0.2. So what is P of z is less than equals to minus 0. Nothing but what? Pi of minus 2. That equals, how can you calculate pi of minus 2? Nothing but 1 minus of 1 minus pi of 0.2. So this can be calculated. This value can be seen from the normal distributed table. From this table, directly you can write down the value of pi of 0.2. What is that value? Equals to 0.5793. That equals to what we got the answer? 0.5793. What? 57.93% you got. So probability that the lifetime of the chips greater than into 4 into 10 power 6 is nothing but how much percentage you got? 57.93%. But what they are given that the deal will be made only if 95% of the batch is greater than 4 into 10 power 6. But only 57.93% are greater than this lifetime. Therefore, the deal cannot be made. Since it is not greater than 95%, the deal cannot be made here. Next question. If a die is tossed, let X denotes twice the number appearing and Y denotes 1 or 3 according as an odd or even number. It means if you get the odd number, 1. If you get the even number, assign as 3. So find the distribution, expectation, variance and standard deviation of the random variables x, y and x plus y. So what is x here? That is nothing but what? Twice the number that appearing in the die. Nothing but. So if you throw a die, what is sample space for that? Is equals to 1, 2, 3, 4, 5, 6. Then what is the random variable? How they are defined? Nothing but twice the number that appears in the die. Nothing but 2, 4, then 6, 8, 10 and 12. So 8, 10 and 12. So if outcome is the number in the die equals to 1, then what is the random variable? X equals to 2. If it is 2, nothing but 4. Like that we are assigning. And what is the random variable? Y equals to? It is 1. When it is 1 for the odd number. So when they get the odd number here, 1, 3 and 5. So when the outcome is 1, 3, 5, then assign the random variable value as what? 1. And 3, if you get an even number in the die. What is even number in the die? 2, 4, 6. So for this 3, you have to assign the number 1. For the even number, you have to assign what? 3. So like that, they have defined the two random variables. Next, what you have to calculate? You have to calculate the distribution function. Nothing but what? Fx of x and the expectation. Nothing but expectation of x and the variance. Nothing but sigma x square and the standard deviation. Nothing but what? Sigma x. For the random variable x, then for the random variable y and for the random variables x plus y. So we'll go for the first problem. So how many possibilities? Then what is x value here? 2, 4, 6, 8, 10 and 12 because which is twice the number on the die. Then what is p of x equals to 1? because 1 is mapped to the 2, then the random variable 2. Therefore, what is p of x equals to 1? Nothing but p of x equals to 2 only. So that equals to what? 1 by 6. And what is the probability that getting a number 2 on the die? Nothing but p of x equals to 2. Nothing but what? 1 by 6. Therefore, p of x equals to 2, p of x equals 4, and so on, p of x equals to 10. Nothing but what? 1 by 6. Because they are evenly mapped, uniquely mapped. Then, we are writing this in the table. So, what is the table here? 2, 4, 6, 8, 10. Nothing but the random variable x value. Next is nothing but what? P of x equals to xi. Next, what you are doing? You have to calculate the mean. How do you calculate the mean? You have to multiply. So, the mean of a random variable x. Nothing but what? Sigma I xi into p of x equals to xi. So, first multiply these two. So, 1 by 6 into 2 plus 4 into 1 by 6 plus 6 into 1 by 6 plus 8 into 1 by 6 plus 10 into 1 by 6 plus 12 into 1 by 6. And what is the variance? For the variance, what do you require? Sigma xi square into pa. So, what is xi square? Nothing but 4, 2 square into 1 by 6, 4 square into 1 by 6, 6 square into 1 by 6, 8 square into 1 by 6, 10 square into 1 by 6, and 12 square into 1 by 6. So, now we'll calculate the mean and variance. So, what is the mean? Already we have seen. You have to add all this. So, 2 by 6 plus 4 by 6 plus 6 by 6 plus 8 by 6 plus 10 by 6 plus 12 by 6. So, that what is the answer? You got 7. Next, how to calculate the variance here? Sigma xi square into p. Nothing but you have to add all these things minus whatever the mean you got, that you have to subtract. Therefore, 4 by 6 plus 16 by 6 and so on. 144 by 6 minus what is the mean of the random variable you got? Previously 7. So, it is nothing but 7 square. Therefore, what is the variance of the random variable? Sigma x square equals to 70 by 6 and mean of the random variable u of x or mu of x equals to 7. And what is standard deviation? Nothing but square root of sigma x square, nothing but square root of 70 by 6. That gives a standard deviation. And similarly, you can calculate for the random variable y also. What is y? Y equals to, if you get the odd number, so if you get the odd number 1, 3, 5. So if you get the odd number, you are assigning a number 1. If you get the even number, so what is y equals to 1, 3. So 1 for what? For the sample space elements 1, 3, 5, nothing but odd number. And it is 3 if you get the even number, nothing but on the die. If you get the even number on the die, then nothing but your assign is what? 3. Then what is p of y equals to 1? Nothing but p of getting the number 1 or 3 or 5 on the die. Nothing but p of y equals to 1. Nothing but what? How many possibilities have we here? 3. Total possibilities are 6. Therefore, 3 by 6. Next, what is p of y equals to 3? Nothing but probability of getting a number 2 on the die or probability of getting a number 4 on the die or getting a number 6 on the die. Nothing but 3 by 6. Therefore, what is p of y equals to 3 by 6? Nothing but what? 1 by 2. Then, what is the mean of the probability? Mean of the variable y? Nothing but sigma yi into p of y equals to yi. And what is the variance of the random variable y? Sigma yi square pi into this is nothing but what? Mean only. Now we'll make a table. So what is yi equals to 1, 3. So what is pi? Nothing but p of y equals to y. Nothing but 1 by 2 and 1 by 2 which we have calculated already. So then this is nothing but what? Yi into pi and yi square into pi. So what is yi square into pi? Nothing but 1 square into 1 by 2. This is nothing but yi into pi. Nothing but 3 into 1 by 2. Similarly, you can calculate yi square. Nothing but 1 square into 1 by 2 and 3 square into 1 by 2. What is the mean actually? So sigma yi into pi. Nothing but 1 by 2 plus 3 by 2. That equals to 2. And what is the variance? Nothing but what? Sigma y square into pi minus the mean here, the mean of the variable y. Therefore, 1 by 2 plus 9 by 2 minus 2 square. Therefore, what is the variance? You got 1. And what is the standard deviation? Nothing but sigma y square. What is standard deviation? Sigma y that equals square root of 1 equals to what? 1. Next, third one is nothing but mean of x plus y. So what is u of x plus y? Nothing but u of x plus u of y. So what is mean of x you got here previously? 7. And what is the mean of y you got here? 2. Therefore 7 plus 2 equals to what? 9. Then variance of x plus y. So what is variance of x plus y? Nothing but variance of x plus variance of y plus 2 into covariance of x and y. So here what is x value? 2, 4, 6, 8, 10, 12. And what is y equals to 1, 3. So they don't have any common elements. Therefore they are independent random variables. So for independent uncorrelated, what is the covariance equals to 0. Therefore, what is the variance of x plus y equals to variance of x plus variance of y. What is variance of x equals 70 by 6 minus variance of y nothing but 1. Therefore, this is the variance of the random variables x and y. And what is standard deviation? So, variance is nothing but you got 32 by 3. And what is standard deviation of the sum of those two random variables? Square root of 32 by 3. That is nothing but the standard deviation of the sum of the two random variables x and y. Next one, a certain large city averages 3 murders per week and the occurrences follows a Poisson distribution. So first question, what is the probability that there will be 5 or more murders in a given week? And second one, on the average, how many weeks a year can the city expect to have no murders? And third one, how many weeks per year can the city expect the number of murders per week to equal or exceed the average number per week? So what they have given that in a city, the average number of murders per week, nothing but let us say lambda equals to 3 per week. So on an average per 1 week 3 murders are happening. And their occurrences are following a Poisson distribution. Therefore, what is x here? Nothing but the number of murders, and it is following what? The Poisson distribution. Therefore, the type of random variable here is a Poisson random variable. So, the first question here, what is the probability that there will be 5 or more murders in a given week? So, what is the first one here? Probability that there are 5 or more murders. Nothing but what? P of x is greater than or equals to 5. You have to calculate. So, what they are given first? They are given that the average murders per week lambda equals to 3 per week. Let x is the number of murders per week. And what is x here? The Poisson distribution. Then for Poisson distribution, probability that P of x equals to k equals to what? E power minus b by b power k by k factorial. What is b value here? Lambda into t. Where lambda is average rate. Where lambda is average rate and t is nothing but the time duration of interest. T is the time duration of interest. So the first question they are given such that what is the probability that there will be 5 or more murders? Nothing but you have to calculate what? P of x is greater than or equals to 5. So what is P of x is greater than or equals to 5? Nothing but 1 minus P of x less than 5. That equals to 1 minus x less than 5. Nothing but x equals 0, x equals to 1, x equals to 2, x equals to 3 plus here P of x equals to 4. Therefore 1 minus, what is P of x equals to k here? Nothing but e power minus b by b power k into k factorial. So what is P of x equals to k? Nothing but e power minus b power k by k factorial. What is b here? Lambda into t. What is lambda? 3 per week. And how many weeks are calculated? In 1 week, you have to, what is the time duration of interest here? 1 week. So 3 into 1, nothing but what? 3. So here b equals to 3. Then what is P of x equals to 0? When x equals 0 means k value 0. So e power minus 3 into 3 power 0 by 0 factorial plus what is P of x equals to 1? Here k equals to 1. So e power minus 3, 3 power 1 by 1 factorial plus and so on. What is P of x equals to 4? E power minus 3, 3 power 4 by 4 factorial. So if you calculate what is the answer I got? 0.1847. What is the second question they have given that? On the average, how many weeks a year can the city expect to have no murders? It means first you calculate probability that no murders in a week. So no model is nothing but what? The number of models should be 0. Therefore, P of x equals to 0. What is P of x equals to 0? Here x value, k value here 0. So e power minus 3, 3 power 0 by 0 factor nothing but e power minus 3. Next they have given in a year they have given. How many? The time duration they have given? In 1 year you have to calculate. So 1 year means how many weeks you are going to have? 52 weeks. So 52 into P of x equals to 0. Therefore 52 into e power minus nothing but 2.5. It means almost 3 weeks in a year will not have any murders. And what is the third problem here? How many weeks per year can the city expect the number of murders per week to equal or exceed the average number per week? What is average number per week here? 3. They have given here what? 3. So P of x is equals to 3. Nothing but what? 1 minus P of x less than 3. So 1 minus what is P of x less than 3? X equals to 0 plus P of x equals to 1 plus P of x equals to 2. So if you calculate what is the answer, you got 0.577. Next, in a year you have to calculate. Year means what? Per year will have 52 weeks. Therefore, 52 into 0.577. Nothing but what? 30.00 means almost 30 weeks will have the average number of murders per week are equal to or exceeds the greater than or equals to the average number per week. Nothing but P of x is greater than or equals to 3. Next question is calculate the probabilities of system error and correct system transmission of symbols for an elementary binary communication system consisting of a transmitter that sends one of two possible symbols, either 1 or 0, over a channel to a receiver. The channel occasionally causes errors to occur so that one show up at the receiver as 0 and vice versa. Assume the symbols 1 and 0 are selected for transmission as 0.6 and 0.4 respectively, and they have given the probabilities like P of A1 by B1 is 0.95, P of A1 by B2 equals to 0.05, P of A2 by B1 0.05 and P of A2 by B2 equals to 0.95. So what they have given that, what you have to calculate? You have to calculate the probabilities of system error and correct system transmission symbols for the binary communication system. Binary nothing but what? You'll have only two values, either 1 or 0. Communication system nothing but you have to transmit and then you have to receive the signals. So when you're transmitting to a channel, to a receiver or a channel, the channel is sometimes making the errors. So if you transmit 1, then it is showing as what? 0 at the receiver. If you transmit 0, it is showing at the receiver as 1. And they have given the probability of transmitting the symbols 1 and 0 are 0.46 and 0.4 respectively. So we are assuming that some the events B1. So what is B1? Let us say this is a communication system. This is a transmitter and it is a receiver. So it is transmitting two symbols, transmit symbol 1 and 0 here. Now we are transmitting a signal, let us say B1 and B2 events. What is B1? Transmitting a symbol 1. And what is B2? Transmitting a symbol 0 at the transmitter. And what is event A1 equals to receiving at the receiver. This is nothing but what? Receiver. Receiving a symbol 1, nothing but event A1. And what is event A2? Receiving a symbol 0, nothing but event A2. And they have given that they are transmitting from the transmitter to the receiver over a channel. And this channel is sometimes causing errors. And what they are given that P of A1 by B1 equals to P of A1 by B1. What does it mean? Probability that receiving a symbol 1 and given that the transmitted symbol is also 1. What is the probability here? 0.95. And what they are given that P of A1 by B2. Nothing but what? The probability that receiving a symbol 1 and then probability that receiving a symbol 1 and then given that the transmitted symbol is what? 0. Nothing but what? P of A1 by B2. What does it mean? Transmitted as 0 given that, but received as what? 1. Then what is the probability is equals to 0.05. And P of A2 by B1. What does it mean? Probability that A2 is nothing but receiving as 0. So probability that receiving at 0 but transmitted symbol is 1. What is that probability is equals here? 0.05. This is A1 by B1. This is nothing but A2 by B2. And this is nothing but A2 by B1 and this is nothing but what? A1 by B2. So the equals to value equals to 0.05. Next, what you have to calculate? You have to calculate probabilities such that the system correct transmission and the error transmission probabilities you have to calculate. Next, what is P of A1? A1 nothing but what? What is that event? A1 nothing but the symbol 1 is received at the receiver. Then what is the probability that is symbol 1 is with the receiver is equals to? This is calculated using what? Total probability theorem. So P of A1 by B1 into P of B1 plus P of A1 by B2 into P of B2. So if you substitute, you get the answer 0.59. Similarly, you can calculate P of A2. What is P of A2? Probability that the received symbol as 0. That equals to what? P of A2 by B2 into P of B2 plus P of A2 by B1 into P of B1. That is the answer you are going to get 0.41. Next, what is the base theorem? P of Bn by A equals to P of A by Bn into P of Bn by P of A. Now, we will calculate the correct system transmission probabilities. What is the correct system transmission? Nothing but what? Probability that transmitted is 1 and given that received is also 1. Nothing but what? Correct system transmission. And similarly, P of B2 by A2. Nothing but probability that transmitted is B2 and received is also nothing but probability that the transmitted symbol is 0 and the received is also 0. Nothing but what? Correct system transmission probabilities. And what is that? P of B1 by A1 equals to P of A1 by B1 into P of B1 by P of A1. Like that, you can calculate the correct system transmission probabilities. Next, what are the error system transmission probabilities? Nothing but what? Probability that transmitted symbol is 1 but received is what? 0. And similarly, what is error? When can you get the error? If you transmit 0 but you are receiving as 1, you are getting the error. Therefore, these two are what? The error system transmission probabilities. By using the base here, we can calculate the current system transmission as well as the error system transmission probabilities. Next one is, a random variable x can have values -4, -1, 2, 3 and 4 each with a probability of 1 by 5. Find mean and variance of the random variable y equals to 3x cube. So what they are given that a random variable x have values for the values -4, -1, 2, 3 and 4. And we should the probability that what? 1 by 5, 1 by 5, 1 by 5. So what you have to calculate? You have to calculate the mean and variance of the random variable y equals to 3x cube. So what is y equals to here? 3x cube. So here you are done here y equals to 4x cube. Then what is y equals 4x cube? Nothing but, so x cube nothing but -4 cube into 4, nothing but -4, 256. Similarly, 4 into -1 cube, nothing but -4. 4 into 2 cube, nothing but 32. 4 into 3 cube, nothing but 108. So 4 into 4 cube, nothing but 256. And then what is the probability here? 1 by 5, 1 by 5, 1 by 5. You have to calculate what? The mean of y and the variance of the random variable y. So you have to calculate the mean of the random variable y. Then what is E of y is equals to yi into P of yi. Nothing but -256 into 1 by 5, -4 into 1 by 5, plus 32 into 1 by 5, plus 108 into 1 by 5, plus 256 into 1 by 5. So look at the answer. Similarly, what is the variance? E of y square minus E of y. Already you have calculated E of y, which you got here. And then you have calculated what? E of y square. What is E of y square? Nothing but -250 square into 1 by 5 plus -4 square into 1 by 5 plus and so on. So that you got the variance E of y square minus E of y equals to 28,728. Next question. A man wins in a gambling game if he gets 2 heads in 5 flips of a biased coin. The probability of getting a head with the coin is equals to 0.7. So the first question, find the probability that the man will win. Should he play this game or not? Second one, what is the probability of winning if he wins by getting at least 4 heads in 5 flips? Should he play this new game or not? So what they are given that a man is playing a game so that if he gets 2 heads in 5 flips, so how many times? Let x equals to number of heads. When you bias a coin, so you'll get the head. Then what is the random variable x equals to number of heads. And how many number of trials, how many times that has been the event, the experiment has been connected. N equals to what here? 5. And what is the probability of getting a head? Nothing but P of x equals to head. Probability of getting head is equals to what? 0.7. Next, what you have to calculate? P of find the probability that the man will win or not. That you have to calculate. It means, so when you flip a coin, what are the possible outcomes here? You are getting what are either head or tail. Then how many possibilities? Having only 2 possibilities. And the experiment has been repeated for how many times? 5 times, because they are given that 5 flips. So since the experiment consists of only 2 outcomes and has been repeated for 5 number of times, the type of experiment is nothing but what? Bernoulli experiment. Therefore, in order to calculate the probability, you can use the type of random variable as binomial random variables, or else you can use the Poisson random variable. We will go for Poisson random variable. If the number of trials are large and the probability of success is very less, then we will go for Poisson random variable. Since here the number of trials are only 5 and the probability of success is 0.6, we have chosen the binomial random variable. Then what is the probability that P of x equals nothing but NCX P power x 1 minus P power n minus x. What is here? N is nothing but the number of trials. And what is x here? The number of times they are getting the head. What is x here? Number of heads. So in 5 flips, how many number of heads you may get? Either 0 times. So at all the times you may get only tail or only 1 head, 4 tiles, 2 heads, 3 tiles. Or else you may get 3 heads and 2 tiles, 4 heads, 1 tile and 5 heads. Nothing but what is x equals to 0, 1, 2, 3, 4, 5. Then what is the first one? And what is the probability that getting 5 heads? Nothing but what? Probability that getting 5 heads. P of x equals to 5. Nothing but what? P of x equals to 5. Nothing but what? NCX P power x 1 minus P power n minus x. Then equals to n is nothing but here 5cx. What is x here? 5 here. 5cx into p. What is p here? Probability of success nothing but 0.6 power x. What is x here? 5. So 1 minus 0.6 power 5 minus 5. That equals to what? What is 5c5 nothing but what? 1 into 0.6. Here the probability of success again is what? 0.7, not 6 again as 7. So here this probability of success is what? 0.7. So 0.7 power 5. This is 0.3. So 0. Nothing but what? 0.3. That equals to 0.16 heads here. So what is the probability of getting 4 heads? Nothing but P of x equals to 4. What is P of x equals to 4? NCX. So 5c. Now what is small x equals here? 4. So P power x. So 0.7 power x is nothing but 4 into 1 minus 0.7 power 5 minus 4. What is 5c4 value? Factorial by 5 minus 4 factorial into 4 factorial. Then what is that value is equals to 5. So like that you can calculate probability of getting 3 heads, 2 heads, 1 heads and 0 heads. So what is the first question? You have to calculate probability that the man will win. When the man will win, they have given that at least 2 heads. Nothing but what? P of x is greater than or equals to 2. If P of x is greater than or equals to 2, then the man will win. Nothing but P of x equals to 2 plus P of x equals 3 plus P of x equals to 4. And probably they are getting 5 heads. Nothing but we have to add P of x equals to 2, 3, 4 and 5. Then what is the answer got? 0.9692. Next, what is second bit here? What is the probability of winning if you wins by getting at least 4 heads in your 5 flips? So at least 4 heads, nothing but P of x is greater than or equals to 4. That is nothing but what? P of x equals to 4, nothing but 4 heads or 5 heads. So what is P of 4 here? 0.36015 plus 0.16804. Therefore, 0.5282. Nothing but what? How much percentage previously? What is the probability you are getting? If you wins the game at least 2 heads, nothing but the probability is 0.969. Nothing but 96% chance you get to win the game. And now if at least 4 heads means what is the probability of getting success? Nothing but 52%. So it is very less. Therefore, it's not good choice when compared to the previous to the thing. So today we have discussed about the problems on the probability and the random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.